Hello everyone, my name is Rashid Ashur and welcome back to the video series where we are solving questions on theory of computation. Today we are going to discuss the end semester question paper. But before we start, don't forget to scan the QR code present on your screen to view my website, see my previous work experiences, projects and the assignments, and to connect with me via LinkedIn or GitHub. So let's get started. The question paper consists of 7 questions and we are going to discuss each one of them one by one. The first part says, give notations of representation the following component of formal languages. And we have given some words and we have to define them. So the first one is alphabet. It is a finite set of symbols and denoted by sigma. For example, sigma is equal to 0, 1 is a binary alphabet. So they are we can say they are the inputs which are given to a string. Second one is string. It is a finite sequence of symbols over sigma and denoted by W. So we have alphabets, that is inputs 0, 1. So we can create strings through using the different sequence of alphabets like 0, 1, 1, 0, 0, 1, 1, 0, etc. Next is empty string. So it is a string with 0 symbols and 0 length. It is denoted by epsilon. So epsilon is nothing but an empty string that has 0 symbols or 0 length but has a string but with no length or symbols. Next is length of the string. So it is a number of symbols composing the string and denoted by mod of W. For example, we have a string 0, 1, 0. So 0, 1 and 0 has 3 symbols in total. So the length of the string will be 3. Next is prefix and suffix. So prefix, these are all the possible leading symbol substrings. For example, for a string, W is equal to TOC, then epsilon, T, TO and TOC. These are TOC are the prefixes. Okay, next we have suffix. These are all the possible string symbol substrings. They are tailing substrings. For example, we have again TOC, then C, OC, TOC and then epsilon are the suffixes. For string W is equal to TOC, you can see in the given diagram on the screen, you can see the substrings and their length. Next we have language. So language is it represents a set of strings over an alphabet sigma. For example, L is equal to ABC, EFG, XY, where all strings are formed using the symbols sigma. So language is nothing but a format of in such a way that these strings are formed and it consists of different strings. So using the alphabets we create strings and the language contains the set of strings. Next we have operators on languages. So we have different operators like union, intersection, concatenation, clean star. So these operators are used to perform various operations on languages. So we have one or more language and we want to perform the operations on them using union or intersection. So we use operator to perform operations on languages. I hope you understood the first question A part. Let's go to next part. So the next part says define finite automata and acceptance of string by finite automata. So finite automata is a mathematical model of the system consisting of set of states and transitions. A finite automata is a 5-tuple system. And what are these tuples? We have 5 different things that together makes a finite automata, that are Q, sigma, rho, Q0 and F. And the meaning of these are set of states, input alphabet, transition function, initial state and set of finite states respectively. Now what is a finite automata? So it is a mathematical model in which we use states and transition to show how a string is made and what is happening in the system. And as you can see in the diagram, we have an off and on automata using push button, push transition. And how does it accepts it? Let's understand it.